1.1 video number 10, and we're looking at theorem 1.7, and the first part of that, if a and b are any numbers, then part I is a times negative b is equal to negative a times parentheses a times b. Okay, so the thing to remember with these proofs, if you notice in the back of the book, there's no answers for 1.1. And the reason for that is because there's many different ways that you can do these proofs. So this is just one of those ways, and each one of these examples gives different ways of attacking a proof. So it gives you a little bit more of a perspective of how to prove a problem. So if you look at, if you were to, let's say, do a web search in YouTube for, a certain proof, and you find a string, a row, several different professors that give that proof, every one of them could give you a different way to do that proof, and they would all be correct. So keep in mind that there's many different ways to do these. So here we have if a times 0, we're going to say if a times 0, excuse me, if a times 0 equals 0. Now you could have used a times x, you could, like we did before, but we're doing a times 0 this time. And we're also going to say, well, let's say, since we need a and b, we're going to say that b plus a negative b also equals 0. Since b plus a negative b equals 0 and a times 0, so we're going to substitute this 0. Since b plus negative b equals 0, we're going to substitute that like it's an x, but instead of 0, we're going to substitute b plus negative b. Okay, so this will be a times, and then where 0 was, we're going to put b plus a negative b equals 0. Okay, so now we're going to use the distributive property, and that's ab plus a times a negative b equals 0. Okay, now we're saying that a times a negative b equals to a negative ab. So we're going to say, all right, since that's the case, then we can say ab plus a negative ab equals to 0, because that's what we're saying here. That's what this proof is saying. So we're going to test that theory and see if both sides equal. Well, ab plus a negative ab, that equals 0, so 0 equals 0, and that holds. Okay, so that's part I. So we're going to take a look at part II. So part II is very much like the first one. And so here we're saying for part II, negative a times b equals to a negative ab as well. Okay, so now this time, instead of a times 0, we're going to use b times 0 equals 0, and we're going to say a plus a negative a equals 0. So we're going to, because a plus negative a equals 0, we can substitute that in for 0. So that's b times a plus a negative a equals 0. So basically this is almost identical to the same process as I. So this is going to be BA plus b times a negative a equals 0. So b times a is ab. And we're saying that negative a times, so this is negative a times b equals 0. So by commutative property, we flip these two. And so we're saying with II that negative a times b is a negative ab. So we're going to change this negative a times b to negative ab equals 0. And so ab minus ab is 0. So 0 equals 0, and it holds. Trying to get rid of this. There we go. All right, so now we've got one more that we're going to do. And that's I. And that one states negative a times the negative b equals to a, just a times b. All right, so now we're going to use ab equals 0. So before we said b times 0. So we're saying if a times b equals 0 and a plus a negative a equals 0 and b plus a negative b equals 0, then we can say that since zero times 0 equals 0, so in that case, if we said 0 times 0 equals 0 and we put in a plus a negative a for this 0 times b plus a negative b for that 0, and we're saying that all equals 0. And we're saying that a plus a negative a. So if we were to use the commutative property, we would have a times b is ab, and a times negative b, that would be plus a times the negative b, and this would be plus a negative a times b, and then this would be plus negative a times the negative b, and that all equals 0. So why did we do this? Because we wanted to show that the negative a times the negative b is equal to ab. So we're saying a times negative b is ab. So this would be ab plus a negative a times negative b, that'd be ab, we already established that, plus a negative A times B. We said that, we already proved that that was a negative AB. And we're saying that a negative A times a negative B is A times B. So we can say that's negative A times negative B is AB. And so now if we group these together, AB plus a negative AB, that's 0. And negative AB plus AB, that's 0. So 0 plus 0 is 0. So 0 equals 0. And it holds. And that's our proof for all three.